SoundCloud. And welcome everyone. So by popular requests, we organized this webinar to learn more about how Tutor works. And well, as a developer, I feel like I understand better how things work when I look at the actual code. And some of you have already taken a look at the Tutor code, and you might already know how it works. You might still learn a thing or two in this webinar. And this is also the opportunity for you to ask questions. Silly questions are more than welcome. Yeah, so I was saying, I've been head deep in this for 2 years. There are certainly things which do not make much sense. Feel free to ask away. Okay, so maybe you can start with the obvious question, which is, what is Tutor? Let me share my screen. I will share my desktop. Does this work? Yes. So Tutor is a piece of code that I created to deploy OpenEdX. And I created that a couple of years ago, and it runs OpenEdX inside Docker containers. And I created that a couple of years ago because I was the native installation was feeling too difficult for me, and it was a pain in the ass. And I thought there might be a way to actually resolve this. So I created something that was initially named OpenEdX-Docker, and it was a Makefile-based project. You can still find it in the history of the Tutor repo. So prior to, I think it was V3. Prior to V3, it was still Make-based. And there were a few iterations until I converged to the actual Tutor, which is a piece of Python code to deploy OpenEdX. Yeah. So before we dive into the actual code of Tutor, I can try to explain why I felt like I needed something like Tutor. So the native installation consists of the configuration repo, and these are actually Ansible playbooks that install OpenEdX on a native server. And these playbooks are really difficult to understand. They're huge. I'm both an OpenEdX, Python, and Ansible expert, and still these deployment playbooks don't make a lot of sense to me. They take a very long time to deploy, and they are not very reliable. They crash pretty often. And I thought it would be that there would be a way to resolve this by packaging all the OpenEdX applications inside Docker containers. This was the time when I was experimenting with Docker. I was relatively late to the Docker game. And so I created a whole bunch of make commands and later Python code to deploy OpenEdX. And really, you could ask, why do we need this? Like, deployment, isn't that a solved problem? Like, aren't there standard ways for deploying stuff? And really, there isn't. And to this day, there isn't quite something that fits the bill to reliably deploy open source applications. Most open source projects provide a Docker Compose file. And most of the time you can run the Docker Compose, run Docker Compose up, and it will launch the app that you want to install. So by the way, is everyone familiar with Docker and Docker Compose? If you're not, feel free to ask in the chat or by unmuting. I don't see all of your faces when I share my screen, so feel free to just interrupt. And yeah,
Just a question there. You said that nothing felt real, but there were several other projects already doing Docker Compose and other things. Was it because of OpenX complexities, or was it something else?
it's something else. It's really something else. So um, usually when an open source project provides a Docker Compose file, there's also right next to it a tiny bit of script to generate passwords, um, sets
Yeah,
environment
the
variables.
secrets.
Yeah, and and so the secrets are actually settings, and because of the OpenX complexity, we needed a way to generate those settings um, um, for every open source user. So there was a piece of code that was needed there, and the piece of code itself is not too difficult, but then we need to make use of those settings, which means to transfer those settings to the applications. So that means that we need to, and usually this happens via files. We need to somehow load the settings in a file, and these files are used by the applications. Um, and this is the second, so these are the first two pieces of features that Tutor provides. It's setting generation and then template rendering. So Tutor comes with a set of templates, file templates, which are rendered by Tutor using the Tutor settings. And then those rendered templates are used by OpenEdX to run. And I didn't really find anything that was quite satisfying to make use of with OpenEdX. So this is why I started from scratch. The right way to do it would have been to just define environment variables and pass them to OpenEdX. But because of the sheer amount of variables and customization of OpenEdX, we had to provide actual templates. So these are the first two components that Tutor provides, settings and templates. Then there are the commands. OpenEdX uses many different commands for provisioning, configuration, administration. This all falls under the umbrella of administration. So when you look at the Tutor documentation, let me share my screen again. Um, when you look at the docs, running, maybe I should look at running OpenNX. Main commands. So these Tutor commands actually cover quite a bit of stuff. First, starting the services, then creating the databases, running migrations, creating users. So because OpenNX is so big, we need to provide an easy way for users to run these commands. And so this is the third component that Tutor provides, an easier interface over many different commands. And again, I couldn't really find anything that would work with an open source project to do that. There was Makefile, and this is why I initially started with Makefile, and then migrated to Python specific code, because it was just so much convenient and much easier, both for me as a developer and also for the end users. And then the last part, the fourth part that the Tutor provides is plugins, extensibility. When you have a single Docker Compose file, it makes it difficult to extend the platform with optional components. You have to manually edit the files, and then because many applications are closely coupled, you need when you make a change somewhere, this change needs to be applied in many places elsewhere. Yeah, so this is the reason why I felt like there wasn't anything else that I could use instead of Tutor. A question so far? No? So if that's okay for you, we can start taking a look at how Tutor works internally. Yeah, I also wanted to make maybe a final comparison with other tools. So Tutor fits a niche that no other piece of software that I could find fulfilled. But then why would Tutor work only with OpenEdX software? My feeling is that Tutor feels a little bit too ad hoc, and maybe it would make sense to generalize Tutor to other pieces of software. The idea that we need to generate configuration, templates, run commands, and have extensibility. This could all work with other open source software, but I didn't yet make this transition from OpenEdX to something more generic. I keep having this in the back of my mind, and hopefully this will happen one day, but no, not yet. Anyway, so the source code. So I have this copy of the source code here on my local computer, and it's a copy from the GitHub repo right there. And so we can start looking at the source code here in my IDE. So the one entry point of Tutor is the actual Tutor command, which you can see here is inside my virtual environment. And Tutor is a Python project, which is pip installed. So if you copy the project locally, you can pip install it in editable mode like this. And once you pip install Tutor like this, then you have access to this entry point, which is the console script, which is located right here. In this module, Tutor commands CLI main. So this is as good as an entry point as any to start looking at Tutor. So let's go there. It's inside the Tutor commands CLI module. So commands CLI. And here we have the main function. So when you run Tutor, it actually runs this main command. And right off the bat, you notice a few things. First of all of the Tutor CLI works with a package called Click, which is a truly awesome project by the same guy who made Flask and Werkzeug and quite a few really, really awesome Python projects. So at first, I didn't think I would need Click. So Click is a package for argument parsing and CLI for the creation of CLI tools. And I thought I could just make up with argparse, the standard Python argparse, but really Click is just so much better. So the Click allows us to do things like nested commands very easily. So there's Tutor local, there's Tutor images, and all these commands find their way here. So this is one of the first things that we notice here in Tutor, in the Tutor code. Then if you write Python code, you might be surprised by this kind of code, like this arrow none thing. This is a recent addition to the Tutor code base. This is typing, static typing annotation. So as you know, Python is not a typed language, and there's a recent addition to the Python, well, recent, couple of years ago, addition to the Python language to say, okay, this object is of this type, and this function takes arguments of this type, and it returns this. So the main function returns none because it doesn't return anything, and it is annotated as such. So whenever I run make test types, it just checks that the tutor source code is properly annotated. And this all works thanks to a project called MyPy, and which was created by Guido van Rossum himself. So we're all in good company here. Another thing you might notice is that there are pylint annotations here. So this is yet another layer of static annotation. But maybe I'll come back to that later. Anyway, so when we run tutor, we go inside this main function, and here we can see that there are quite a few commands. So the CLI, so this is the actual tutor command with a big warning saying, hey, if you're running as root, you should probably not do that. You're probably doing things wrong. And then we add subcommands to the tutor command. Let's dive into one of these commands. Maybe I'm getting ahead of myself. So let's take a look at the config command. So I went into this, let's go into this config module. So in Tutor, every command, the code for every command is stored inside a dedicated module inside of the commands folder. So if you're looking for the local command, it's fairly easy. It's inside the local module, inside the commands folder. And the reason why I'm interested in this config command is that it's at the very beginning of the tutor process when you first install OpenNX. So I told you that Tutor resolves the issue of generating settings and generating templates. So the first thing that Tutor needs to do is to generate settings. And Tutor needs to persist these settings locally because you need to store secrets. And Tutor stores these settings in a place which is called the Tutor root. And by default, it's inside .local share Tutor, because this is the standard way of doing things as provided by a small library called appdears. Why can't I find it here? Appdears. Yeah. So appdears provides the standard Tutor root location here. And so that means that all data will reside in this folder. And this has several benefits. First of all, it makes it very easy to investigate where things go wrong with Tutor. You just have to look inside this folder. And Tutor will not install anything outside of this folder. Then it also means that if you want to run several OpenNX environments next to each other, you just have to have different roots for these projects. Anyway, I was talking about the configuration, the Tutor configuration. So let's take a look at this. Let's take a look at this configuration file. And as you can see, it's mostly secrets there. Secrets that Wait a sec. I might be sharing some stuff here that I shouldn't. Am I? Let's stop sharing. I just want to check something.
It's already recorded, man.
Yeah, but I can still blur. I can still blur. No, I think that's okay. I didn't store any. I didn't show the e-commerce secret key, which is good because. And also I want to delete some other stuff. No, I don't want to delete that.
Free licenses of Tutor for everyone watching this and who took note of that code.
Can you see that I didn't prepare well enough for the presentation? Did you notice?
Nah, that's nothing. Once I went to a, what was that called? It was a webinar, but when it was one person, in person, and I committed the AWS secret key to a
Awesome.
template repo that I was doing, and I got the message from GitHub. Like I was preparing my talk, committed, got the message from GitHub, and I said, great, now on top of preparing this, now I have to go change all my passwords in production right now. So, a great day.
Okay. Oh, so questions from Florian. Is this config.yaml file fundamentally identical to what we say in find lms.yaml or cms.yaml? So Florian is asking, what is the connection between this configuration.yaml file and the lms.yaml or cms.yaml file in OpenNX? So quick answer, completely different, and we'll see why in a minute. Share screen again, share. So let's take a look at this. So there are still secrets there, but that's okay because that's only for my local installation. And all these secrets are different from one user to the next, which is why we need to persist them in a file. And this is a long file, but not as long as, say, the LX platform settings file. So here you see that there are 89 lines, so less than 100 lines. And this includes settings for quite a few plugins, including the Notes plugin, the XQ plugin, and something which I failed to develop live last time I did a live stream, which was the status plugin. You can see that there's also like the LMS host, like at which address do you intend to run your platform. And here it's local.overhang.io, and you'll see why in a minute. And then there's also the platform name, the language code of your platform. Here it's English, etc. And you really don't want to lose this file if you deploy to production. You really might want to store this somewhere safe. Maybe version it to your in a secret place, in a secret repository. Do not commit this to a public repo, obviously. So you might want to keep this in a safe place, because this is the file that you use to generate the entire Tutor environment. And what is the Tutor environment? The Tutor environment is stored in the env folder, and it's the set of files which are used to run OpenMX. And these files are generated from templates. Let's take a look at one of these templates, like the local Docker Compose template. So this is a Docker Compose.yaml file, except that it's a template. It's not going to work out of the box. It's going to be rendered to an actual file before it is parsed by Docker Compose. And you can see that it includes quite a few Tutor configuration variables, like if run MongoDB, then actually run the MongoDB service. And run MongoDB is not an edX platform configuration settings, but it's a Tutor setting. So I believe this answers your question, Florian. For instance, if we look at the, so we can print the value of just any configuration variable with the tutor config print value command. And here we can see that it's true. So I do want to run the MongoDB service on my local system. And this variable might be false for people who run hosted MongoDB. Like they have a separate MongoDB cluster, or they run on Amazon hosted MongoDB, so they don't want to run MongoDB locally. And this is all explained in the tutor docs, albeit I must admit in rather terse terms. Yeah, so here you have run MongoDB, which defaults to true, and here's explained why we need it. So it's a bit brief, but yeah. I guess we could expand the docs here. Anyways, so we have this Docker compose.yaml file, and this will get rendered to an actual Docker compose file in the environment at the exact same place inside the local folder and in the Docker compose.yaml folder. And if I look at this file, then we can see that it's an actual valid Docker compose.yaml file. There's no if run MongoDB then. And the templating language that we use here is actually Jinja 2, which I by some coincidence is, I think, written by the same guy who wrote Click. So yeah, it's a Palettes project. It's only partially a coincidence. It's only a coincidence because the guy is the team is so great, so they create such great software, such great software. I would be happy just with creating Click or Jinja 2. They created both. Anyway, yeah, mad skills, mad respect to these guys. Anyway, so this means that inside the tutor templates, we can use just any tag and filter that are available out of the box in Jinja 2, including, no, not here. Yeah, including if conditionals, loops, etc. So I thought this was a great fit for generating templates. And here so tutor config generates templates, both for Docker Compose, but also Kubernetes, and also settings files. So if we look at the production settings for the LMS, it also makes use of Jinja 2. And here we say, hey, if we enable HTTPS, then the session cookie is secure. So these are all the familiar Django settings files. So to come back to Tutor, so Tutor, you both define new variables and save the environment at the same time. So when you run tutor config save, how can I put this? Well, I'll show. You know what? I'll show it to you. Let's take a look at. I told you that the config.yaml file was important. So what I'm going to do is actually remove the env file. And I told you that the env file contains everything that you need. For instance, it contains the settings for the for edX platform. Contains the production settings. But you know what? What I'll do is that I'll just remove this RMRF. What do you mean? Can't remove release conf. Okay, this is probably because of old trials and errors. So I just removed the env file. But that's fine. That's fine, because when I run tutor config save again, it regenerates the env folder using the config.yaml file. And I can, again, find the same configuration setting file that I had before. So really, config.yaml is a source of truth for any Tutor installation. So we're already halfway the meeting, so I'd better accelerate a bit. So you can define new settings using tutor config save set and then foo equals bar, and this defines a new variable called foo, and it's stored inside the config.yaml file. And you can always remove it using tutor config save unset foo. And you no longer have the foo variable inside the config.yaml. So this is why this approach really makes it very easy for people to change their configuration. So whenever they want to, something that is very difficult with the native installation is changing the LMS host. Here it's as simple as running tutor config save set LMS host equals my beautiful domain .fr, because I live in France. And all the environment will be regenerated using this new host. And then you can run the platform with HTTPS and everything, and it will all work out of the box under this new domain.
If I'm editing multiple variables, can I just open the config YAML, alter some things, and then use some tutor command to load that into the end?
Yeah, exactly. So let's try this. So the question is, if I want to avoid using this rather cumbersome command, can I just edit config.yaml and edit the LMS host? Yeah, sure. And then just run tutor config save. And this will regenerate the environment using the variables from config.yaml. And then you can check that it's all used everywhere in the environment. So to come back to this. So the config module actually saves stuff to config.yaml. And for that, it loads configuration settings from different places. It loads them both from the actual config.yaml file, which already exists. And it also loads them from the default config.yaml file. And not all, and this is stored in the Tutor source code. And these are default values which are not necessarily stored in config.yaml. For instance, the run MongoDB variable, which we saw earlier, it's not stored inside config.yaml because if it's not a secret and it's still the default value, there's no point in storing it there. And the other source of truth for these variables is the environment. It's possible to load Tutor configuration settings from the environment. Just no, wait. Where's that? No, wait. Config I'm lost. Tutor config commands config. So the logic for the Tutor configuration happens in the config module which is not to be mistaken with the config module stored in the commands folder. So there are two different config modules in Tutor. The defaults are loaded by load defaults, and then the existing values for the running platform are loaded from the user, like the config.yaml file, and also from the environment. So this load env function checks all environment variables prefixed by tutor env, by tutor underscore, and it will read the variables from there. So for instance, tutor config print value lms host. Here it's puac.fr, and then if I run tutor config save with lms host foobar, tutor lms host equals foobar, and run tutor config save, then the lms host should now be foobar. So these are the three places where variables are loaded from: config.yaml, user config, defaults config.yaml, user config.yaml, and then environment variables. And once all these variables are loaded, Tutor is able to render the templates using this env save function. And so this saves the actual environment, and all the code related to the environment is stored inside the env module. And here it says, hey, look at all the files in this folder and just render them and store in the env folder for the user. Which is why I'm able to remove and recreate the env folder whenever I want. Oh, many questions in the chat. Shit. Yeah, so I don't have the chat notification pop-up, so I don't see the questions. So Andres asked if we can edit this config.yaml manually. So yes, we can, as I explained. Do we have a directory of all possible variables? Yes. So all possible variables are stored in the default config.yaml file. And the thing is, so you can be absolutely sure that all variables are there, because when we open a file, a template, and we just ask it to render some non-existing variable here, and I run tutor config save, it's going to crash because this value here is undefined. So all variables need to be defined somewhere, and they're all, so you can be sure that they can be found in this default template. Oh, well, it's not really a template. It's more like a YAML file. And by the way, you can see that the values for these variables are themselves Jinja2 templates. So for instance, the JOT common secret key is actually the same as the OpenEDX secret key. And here, the RSA private key is randomly generated. Now that's interesting. What? This shouldn't be here. I'll have to take a look at this. What else?
Massive redesign of Tutor coming up after that.
What else? Yeah, so if you define a different Docker registry which is different than docker.io, then all Docker images will be labeled, what will be pulled from this different registry. Yeah. So configuration, environment, then what we have is commands. And Tutor provides convenient commands such as Tutor local create user, or famously Tutor local quick start, which is the one-click installation of Tutor. And again, so this local command is defined in the local module, in the commands local module. So if we take a look at the quick start command, you can see all the stuff that it does. It's all there. So there's if there needs be a major upgrade, then upgrade the thing. So from Ironwood to Juniper to Koa to Lilac, and then interactive configuration, which these questions here. Are you configuring a local production platform? No, I want to run locally. Because it runs locally, then it will have this LMS host, a platform name, contact address, language, and that's it. And then we stop any locally running platform with basically Docker Compose stop. If need be, then pull images, and then start the platform, and then run init. And initialization is database creation, migration, making sure that all the waffle flags are set, all kinds of stuff. All the inits hooks, so these are called hooks, are stored, are commands which are stored inside actual init templates. And again, these are templates. So you can add Jinja code there. So for instance, the CMS init command waits for the MySQL host. And then, yeah, that's basically it. In the LMS, yeah, we just need the MySQL host. Questions so far? So, no, nothing in the chat. So there are only 10 minutes left until the end of the meeting, and there's so many things we didn't cover, like what happens when you do Tutor images build OpenNX, or what happens when you do what? What else is there? Like, what's the difference between Tutor local and Tutor K8s? And what actually does, well, no, it's not Tutor local K8s, it's Tutor K8s. And by the way, what does Tutor local do anyway? And what does Tutor dev do? Dev makes OpenX work in a development environment. So the common thread between all those commands is that they're only really very thin wrappers around other tools. So Tutor local is mostly a wrapper around Docker Compose. Tutor K8 is mostly a wrapper around kubectl, and Tutor images is really a wrapper around Docker build, push, pull. So the way these work, let's take a look at the images command. If we look at the build command, then basically we just create a bunch of Docker image build options and pass them to the build image function, which is itself a wrapper on top of this build thing, which calls utils docker, which itself calls docker, execute docker thing. And there's just a light check here saying, hey, if you didn't install Docker, I can't do anything for you. Yeah. So there's nothing special about those commands, but maybe it's worthwhile to take a look at the Docker file for these images. Docker files are also Jinja 2 templates. So here we have the Docker file for the OpenEDX image, which is used both by the LMS and the CMS. So this creates a production image, and the development image will use this production image. Anyway, so this Docker file also includes some Jinja code, but it's really much more lightweight. There's not much in terms of Jinja code, and there's a reason for that. The reason for that is that the Docker images do not come with any user-specific configuration out of the box. This is really, really important. We want to ship images that anyone can use. And so we don't want to have a user-specific configuration there. On the other hand, we want to enable users, Tutor users, to build custom OpenEDX images. So we want to enable them to easily add some content to the Docker files. And I really, really don't want anyone to fork the Tutor repo just so that they can add their own content to the templates. Which brings us to the last piece of the puzzle, which is plugins. OpenEDX suffers from severe fragmentation. Everyone forks edX platform to add their own code there. And I did not want to face the same problem. I didn't want people to fork Tutor so that they can add their own custom command, and when the time comes, they need to upgrade, and they never do because it's such a pain in the ass to rebase changes on top of someone else's. So I created this plugin system, which is really not very complicated to be. It's fairly basic, to be honest. So the plugin system consists of a few things. It's all documented here in the plugin API. So like I mentioned, Tutor is mostly configuration settings, templates, and commands. And that's really all there is to Tutor. So we need to enable people to add stuff to configuration, to templates, and to commands. And for that, it's possible to create plugins that will add stuff to each of these three components. And I'm talking about this because I was looking at this Docker file template, and we can see here this patch statement. And this patch statement actually means, hey, any plugin developer can add stuff right there. By the way, this patch was contributed by EduNext. Thank you, EduNext. And the way we can add stuff there is by implementing a patch which has this name, OpenEDX-Dockerfile post Python requirements, which will mean after installing all the requirements, please insert this tiny bit of code in the Docker file. And this is tremendously useful, for instance, for production settings. So the production settings has this OpenEdX LMS production settings, which enables any plugin developer to add production settings right there. And because sometimes we want to add custom settings, not just to the production, but also to the development settings, and both for the LMS and the CMS, there are partial templates. So for instance, this common all template, which has this batch statement OpenEdX common settings. So you can add stuff there as well. And most of the Tutor templates have at least one batch statement at the end. So the message that I'm trying to get across here is, please don't fork Tutor, please create plugins. Much better for everyone. So how do you implement those? You create a plugin. There are two different ways to create plugins. You can create plugins under the form of YAML files or Python packages. YAML files are very easy to create, but they will not provide you with the ease of use and ease of development that you need if you want to create some more complex plugins. So for instance, if you want to add some new templates, I don't even think that would, well, yeah, that would work, but then you would have to write your templates inline here in the YAML file, which is very inconvenient. So for instance, recently I created this gist, which is a very simple Tutor plugin to disable Google Flock, which, to be very honest, I don't understand everything about Flock. What I understood was that it was really terrible, and it's very easy to disable by adding a simple header to your OpenEdX platform. So this very simple plugins implements two different patches. This Nginx LMS patch adds stuff to the Nginx template here at the very bottom. So this will simply add a header to all the requests, all the responses to the LMS. And same here for the CMS. So this is one way to create plugins. And if you want to create more complex plugins, you are encouraged to create an actual Python package. And for that, you need to implement a specific entry point, which is Tutor plugin v0. And in this plugin module, you should add config, hooks, commands, and templates. And because it's a bit of a pain in the ass to start from scratch, there's a nice cookie cutter here, which I myself use to generate new plugins. So to come back to the plugin API, plugins can add some new settings. So we can add either new defaults. So for instance, this plugin will add the Docker image setting. So this setting will the name of this setting will actually be prefixed by the plugin name. So it will eventually be my plugin Docker image. It can also, so these are defaults. They will not be saved to the config.yaml unless they are overridden. And if you want to add secrets, then you want to add configuration settings under the add key. And there's even a way for you to override existing settings. And these overridden settings here will not be prefixed by the plugin name. So it's a bit of a hack, but it was necessary in some cases. And this to answer your earlier question, Andres, where do we find a list of all configuration settings? So not all of them are listed in config.yaml. Some of them are declared by plugins. And there is currently no way to list all of the configuration settings by all plugins. I guess it would make sense to create a tutor config list command to list all of the settings. So I covered some ground here. We're running short. I can still extend this presentation a little. Maybe you guys can have. Do you have questions on particular topics that you would like to see clarified? Are some things that are unclear?
So you've added, I think, Caddy on top of Nginx. I don't know if you want to talk a bit about why you did that and what does it mean for plugins.
Sorry, Nginx?
Caddy on top of Nginx.
Caddy on top of Nginx. Okay. So in Koa, I made quite a few changes to how Tutor works, to how Tutor deploys OpenNX. Prior to Koa, the web server in front of OpenNX was Nginx and only Nginx. And Nginx was in charge of many things, handling SSL certificates, redirecting to HTTPS when there was an HTTP request, and quite a few other things. And in Koa, I decided to add a layer on top of Nginx. And this layer was Caddy. And Caddy is now in charge of generating the SSL certificates and passing requests to Nginx. So if we look at the actual Caddy configuration, it's inside a Caddy file. So it's fairly simple. Really, all it does is intercept requests for the LMS and the CMS and forward requests to Nginx. And here there's this patch statement which says, hey, if you want to add stuff there, it's as easy as implementing this Caddy file patch. And prior to Caddy, people had to implement all sorts of patches. They had to add patches to very complex patches to Nginx. They had to handle the HTTPS redirection. And also there was a Let's Encrypt init script where they needed to add stuff themselves. Whereas now all of the SSL stuff is handled by Caddy. And that's all Caddy does. Caddy doesn't do anything else. And I intend to keep it that way because, well, ideally, all of the Nginx configuration would be moved to Caddy, but I like the way Nginx handles the configurations. It's really quite readable, and people would have to rewrite all their plugins. But if you create a new plugin from scratch, you are perfectly allowed to just intercept traffic in Caddy and just forward to your containerized service and not go through Nginx at all. But I figured Nginx works well, it's very convenient. Let's not get rid of it for the time being. Does that answer your question, Sofiane?
Yes, yeah. So that's what I wanted to understand. If we make a new plugin, do I then need to add a Caddy patch and an Nginx patch, or?
Yeah. You probably want to implement both this Caddy file patch and the Nginx extra patch. So you see here, there's this extra conf file, which is empty and which is used by any other plugin to add stuff there. So for instance, the e-commerce repo, it's good to really look at other plugins. And this e-commerce repo, e-commerce plugin adds stuff to Nginx Extra. And it's a simple redirect to the e-commerce container. The reason why I recommend not adding too much stuff to the caddy file is that I recommend to disable caddy when running a proxy in front of OpenLX. Many people run OpenLX on a web server next to other applications such as WordPress or, God forbid, Moodle, or maybe other OpenLX platforms. So they want, in such cases, they want to disable caddy and handle SSL generation, SSL certificate generation themselves. And in such cases, I recommend to disable caddy and this is documented somewhere. Wait. Let's search for run caddy. Where's that? Run caddy. No. Local deployment. Yes. So for instance, when you run OpenX behind a web proxy, you want to disable caddy, run Nginx and expose a different port, and then forward your custom proxy to Nginx. So I recommend not adding too much stuff to the caddy file, because when it's removed, then you don't have it anymore. There was something else I wanted to talk about, and I will mention it very briefly. It's how I test Tutor code. And after all, this is a Tutor source code 101 introduction. The gist is that whenever you make a change, you should run make test. And you will see that make test actually runs multiple tests. First, it will check for static errors with bylint. Then it will run unit tests. Unit test coverage is not great. Like the click commands are not unit tested, but it's sufficiently good. And then after running the unit tests, there's the static typing. So you need to make sure that your code is correctly annotated, otherwise you will get an error here. And finally, there's a check that the code is properly formatted using black. So this is controversial. I'm not sure black is the best formatter around here, but it is unequivocal, which means that you run it, there are no option to pass to black, so it just works, and you can use it to reformat your code, and it's very consistent, meaning that it always produces the same result every time you run it. So overall, I think it's quite a big benefit to a code base. And then there are there's make test also checks that we can actually bundle the Tutor OpenLX package, and this is a test that pretty much never breaks, so you should be fine with that. And you can run each test separately by running make test lint format types Python package unit, and you can have information about all commands with just make. So when you develop on Tutor, you should really run make test. Yeah. Other questions, maybe? Um,
There are a couple of questions in the chat.
really? Whoa! I missed all those. Oh, Zoom. Ah. Okay, so I missed Florence questions from 30 minutes ago. The tutor environment variables are evaluated at the time of tutor config, but not at OpenEdX runtime. Yes, this is correct. So the tutor prefixed environment variables are stored inside config.yaml, and these values are used by um, the template rendering system to generate the OpenEdX settings files, the Docker Compose files, etc. So once you have generated the environment, you can run pretty much all the tutor commands um, um, confidently. Um, so Journey asks if config.yaml could be overridden via plugins. Yes, you can override values from from core tutor with these config set here. So for instance, you can override there's no master password configuration, but you can override I don't know, the LMS host. You can override the MySQL password if you want. So this is nice ways for you. This is nice way for you to make sure you just install a plugin and you have an infrastructure that is consistent with your existing installation. Like you have an existing MySQL password, just create a plugin that stores all of your passwords. Um, but that also means that if you're not careful, if you install someone else's plugin, then this plugin will be able to override all of your settings. So this is, be careful when you install plugin. Basically, I think there's a warning. There's a warning when you install a plugin that overrides um, to your core settings.
Mm. But Regis, what would be the best practice to make the customization? To write the config YAML or to write the plugin to change the settings?
It really depends how you want to distribute your changes. If you want to distribute your changes to many users, then definitely write a plugin. If you have a single deployed platform that you want to um, to deploy consistently, then just store the config.yaml file. Just version it. Yeah, keep it safe. Keep it safe. It's just much more simple than creating a plugin. But on the other hand, if you create a plugin to add some customizations, then well, you will have to create a plugin. So you'll have to handle both um, the plugin and the custom config.yaml file.
Another question about this: how do you push these changes to the production files, to the production containers?
So this is a good question. The configuration values are not used to generate the Docker images. They are used at runtime to run the OpenX platform. But you should really be careful not to include any configuration setting inside your Docker images, because otherwise it will mean that every time you make changes to the configuration, you will have to rebuild your Docker images, which is a pain in the ass, and which we will have to do with micro frontends, but that's another story.
That's a pain in the ass for another day.
Yeah.
But is it not recommended by Docker to have your secrets and perhaps configurations in the Docker image already? If
No.
you are managing the infrastructure that way, I mean, of course, you need production to be expecting them.
No, I honestly think it's not a good idea because it will really slow you down, and it's just so much easier to mount the secrets at runtime. Mount the secrets as either volumes or how do you call that in Kubernetes? Config config variables. I forget what's the term, but there's
Yeah,
a way to
Kubernetes
mount.
has something for that.
Config maps.
Yeah, config maps. Yeah, exactly. Or environment variables. Many different solutions, but really don't have a Docker image that contains secrets. So going through, does that answer your question, Andres?
Yeah, I think so. Yeah.
So your next question was, how does comprehensive theming work here? Comprehensive theming is the way you customize the appearance of edX platform, and Tutor provides some convenient commands for you to have a quick feedback loop with when you develop the custom themes. But you really have to understand that Tutor plugins have nothing to do at all with edX platform plugins or comprehensive themes. Really, completely different beast. What Tutor plugins can do is install custom packages, maybe custom themes inside the Docker image that you are building. And so Tutor provides some convenient functions for working with comprehensive theming. This is documented here. Configuration and customization, custom OpenEdX Docker image, adding custom themes. And there's a way to do that. So I'm not totally, I'm basically telling you, read the fucking manual. It's, honestly, every time I need to implement a custom theme, I go back to this documentation to read the instructions, because you need to be very careful about these. You need to mount the theme in the proper folder, and otherwise it will simply not work. But basically, you need to mount the theme inside the image, build the theme at the same time as you build the Docker image, and then your Docker image will have the theme included. Does that answer your question, Andres?
And would it work to mount an external folder so that the Docker file can read in order not to build a new image just because I change a CSS or whatever?
Yeah. Okay, so there's no way to do that. But let me clarify. So first of all, when you build a Docker image, you do not mount a volume inside the image. What you do is to copy files from the Docker context inside the Docker image. And this was really a big misconception that I had in the beginning when I first started work with Docker. The Docker image copies files and folders from the context to the Docker image. So the way you do it is that you would copy the theme folder inside the Docker image when you build it. And your question was, how do we avoid a very long feedback loop when developing a theme? And because if you need to rebuild the Docker image every time you make a change to CSS, then you're up for hours and days of work. Pain in the ass. You don't want that. You don't want that. So Tutor provides you with some convenient commands there that allows you to do them. Let me share my screen again. Share my screen. Um, So you want to look at running OpenNX, development, and customize themes. So you want to run OpenNX in development mode with a convenient watch themes command, which will watch for changes inside your bind mounted folder every time. So every time you hit save, it will automatically recompile the theme, so that when you hack on the theme, you don't have to rebuild the image, and you will iterate. And once you are done with your changes, you can actually stop the dev command, build the production image, and push it to production. And this is how you do it. This is how you have this tight feedback loop. And this is how I developed the Indigo theme. I think I actually created this watch themes command because I was developing this Indigo theme. Does that make sense?
Yeah, so to summarize, when I make a change in a theme, okay, after debugging and so on, once it is done, I have to rebuild the image and push it to production.
Yeah.
Okay.
So this is really the Docker way of doing things. I tried to make it as fast as possible to build the Docker image, such that you don't have to redo everything when you change something in the theme. But it's still going to take a while. Yeah. So the way I do it in CI is that I run image builders inside Kubernetes. So so building images is actually a scalable process. But this is a little bit more advanced. So so your next question was, there's no need to create SSL certificates. Yes, yeah, this is correct. With Caddy, there's no need to generate SSL certificates yourself. Caddy generates them transparently, and it really works very well, I think. So it does a really good job. What's not so good at is reporting errors when a domain name is not correctly configured, and this causes issues for some people. Next in line, Florian said goodbye. Yeah, too bad we had to lose you, Florian.
I was curious about the fact you mentioned that you are running your CI inside Kubernetes. Are you using something like Canico or something?
So I'm running Docker in Docker. So this is the Tutor CI does not run on GitHub. It runs on GitLab, on my self-hosted GitLab, and the GitLab workers, the GitLab runners run on Kubernetes. And so that I do Docker inside Docker. So there is a separate Docker host, which runs inside Kubernetes, and the workers build by connecting to this Docker host. So it's not like completely scalable, because this Docker host is a single point of failure, but it works sufficiently well. It's really quite performant.
And from there, you update the Kubernetes cluster state. I'm referring plus to the CD part.
So you mean like what do you mean state?
If you build a new image and then you need to update the Kubernetes cluster, it's just like running with Tutor K8s start or something, or how do you?
So I don't self-host OpenNX on Kubernetes. So Kubernetes, in my case, Kubernetes is only used for CI. The demo OpenNX platform that I run runs on a single server, because the local installation is really my primary concern, and I want to make sure that it keeps working all the time. So I only test the local installation.
Okay.
And if I had to do it with Kubernetes, I would build the image in Kubernetes, push it to a registry, either docker.io or a self-hosted registry, and then so push the image with a new tag. This is important. And then tell Kubernetes, okay, now the LMS needs to run with this tag. If you don't have different tags, if you keep having the same latest tag, then you need to tell Kubernetes to check periodically for changes to the registry. Does that answer your question?
Yeah, in fact, we were considering using tools like Argo or Flux to automate, like somehow use a repository to save the rendered templates from Tutor, the Kubernetes manifest files, and then somehow create a routine that keeps tracking that repo for changes, and it automatically updates the Kubernetes cluster.
I'm not sure I would do it that way. Watching for templates. No, I don't think this is. Do you want to auto deploy like without even knowing about it?
In fact, we want to automate the pipeline. So you start developing a feature, and then there is a CI that automatically builds an image. And once the image is built, the tutor configuration is run. So the Kubernetes manifest files are updated, and then automatically it gets deployed to the Kubernetes cluster, obviously with very strict filters on every step to make sure that the thing is working as expected. And but yeah, it's basically to know your opinion about this. You know Tutor very well, so maybe there's something I'm not spotting.
Yeah, maybe it's the right way to do it. It's okay. So first of all, you're going to have to watch not only the templates. Well, it's not going to be enough to watch the templates, because so imagine the template for the Docker file changes. Then okay, you need to pull a new image, but then you have to wait for the image to be built. And then you will want to pull the new image. So you should be watching for the Docker registry. But if you only watch the Docker registry, you will miss changes in the settings. So you are right that you should be watching the rendered templates. However, it's weird that you have to keep the environment under version control. Instead, you should only have to keep under version control the config.yaml file. You see what I mean? Well, it's a bit more.
Yeah, from the config.yaml you generate the Kubernetes, because those services like Argo and Flux are tracking a GitHub repository. So once you push a change on that repository, the changes on the inside the Kubernetes cluster happened automatically.
Okay, so I think the right thing that you need to monitor is the config.yaml, tutor version, and the plugin versions as well. Because the tutor version and plugin versions are not stored inside the config.yaml. And when you upgrade a plugin, you will make changes to templates, but really you don't want to version the templates because the templates are automatically rendered with tutor config save. So Argo or something else could be running tutor config save using the config.yaml. Am I making sense?
Yeah. I understand. There's an additional step. Okay, we need to track only the tutor related versions and then make Argo do the job to run tutor config save of whatever it needs, and then from there fetch the changes.
Yeah. Well, regenerate the env, the env, and then build the images, and then push the images, and tell Kubernetes, okay, you should be pulling the new images. kubectl start, basically.
Okay.
There was a question from Eric about, have you considered serving theme static assets from S3? So this is a big topic that comes back quite frequently. The common understanding is that it's not efficient to serve static assets from micro WSGI, because this is what happens right now. Static assets are served by micro WSGI in the OpenX container. And this was also one of these changes that I made in Koa. And you know what? Actually, how do you call that? UWSGI? USGI? Micro WSGI? Okay, anyway, this component is really efficient at serving static assets. So I did not feel the need to serve static assets from S3 or from any object storage layer. However, if you want to do it, it's not so difficult. It's really not very difficult. What you need to do is first run the asset collection step by pointing to S3, and this you can do after building the image. So you run so you mount your settings, your Django settings that include S3 connection strings. So you mount the settings inside the Docker containers, run the collect static command. So the static assets are shipped to S3, and then you run OpenX with an additional setting, which is, hey, you really should be serving static assets from this URL. So all static assets URLs inside HTML files will be prefixed by the CDN domain name. Does that make sense?
Yeah, I wonder if serving them from S3 would help in avoiding rebuilding the image every time you do changes in the theme, because you will need only to gather static assets again instead of rebuilding the image. I would wonder if.
Yeah, I guess. Yeah, I guess so. Yeah, that's an easy way to quickly put static assets in production. Basically, you're developing in production. You're like, hey, I'm hacking on this comprehensive theme and pushing it to production in one go. So yeah, this is one way to do it. That's an interesting. Yeah, that's cool because it's a solution to a problem that many people face. Many people don't want to bother with the development environment. They just want to ship to production, and I'm personally fine with that. And yeah, it would be a good solution. So yeah, it's a good idea. Maybe I would not store static assets in S3 because I could not care less about AWS, but I would store static assets in Menio and push static assets to min.io locally. Yeah, that would be a cool project.
Okay, thank you.
Do you have anywhere the instructions to configure S3 or min.io as the source for static access?
No, I didn't, because I did not develop such a plugin until now. So every time you need to create a plugin, the source of truth is the OpenEdX source code. So you need to deep dive into the LMS and CMS settings and figure out which ones you should be concerned about. So actually, for static assets, this is mostly standard stuff, standard Django stuff. So you should take a look at the Django docs. Yeah. So it's only like a few settings that you should change. It's not very difficult, which is why I'm interested in developing the plugin, because it's not very difficult.
It looks like there will be a lot of people writing plugins and stuff and extensions for this. Do we have where should we publish these the plugins, and will there be a marketplace or something, some place centralized so that everybody looks and finds plugins and things we are developing?
So I think the first place to show off your plugins should be the Tutor forums, and I guess I should be creating a new category like Tutor plugins, where people can announce new plugins, and people can ask questions about them. This is what happens for Discourse. So the Discourse software, people announce plugins in a dedicated forum category. I think this is good. We're not there yet. We're not at the point where there are dozens of plugins lying around and just waiting for people to install them. So I'm not going to create a marketplace right away. I wish that this is something that I have in the back of my mind, to create a marketplace where people can, I want to be the Google App Store of OpenEdX and make bazillions in the process. No, but seriously, I would love it if people could make money by selling to their plugins. I think it would make a lot of sense. And it doesn't make sense for people to re-implement their own marketplace. And at some point, I hope that there will be enough plugins that people will suggest, hey, I will build a marketplace. And I hope this person will be me. I just love to create a marketplace where people can just check plugins and buy them or download them for free, just like for WordPress. This is an idea that I float around. I would love if OpenEdX SaaS providers could provide hosted services for self-hosted OpenEdX users. Like, you are running your own OpenEdX platform, self-hosted, but maybe you want to run a hosted service like a status page or backups, anything. And I would love if providers could have an easy distribution channel for the plugins to provide value to these self-hosted people with those commercial plugins.
Yeah, I mean, commercial or not, maybe for free, but just a single place where you can look for something and find.
Yeah, basically an app store. Yeah, it doesn't have to be to be commercial. Right now, the source of plugins is PyPy. You just pip install plugins, but there's no discovery mechanism. Yeah.
Maybe you could also use a GitHub tag to get plugins, and people search GitHub for that tag.
Genius. The GitHub tag. There is such a thing. Okay, yeah, this is a good idea. It's probably not sufficient because GitHub is really aimed at developers, and we need to expand the audience here. But yeah, it's a really good start. Yeah.
I don't think it's called tags actually. It's something else, but you can essentially have.
Yeah,
If you
topic.
search for open events topic, yeah.
Yeah, I can see that. Yeah, great idea. Great idea. Yeah. Guys, I'm gonna have to go. So if you have further questions, maybe ask in the forums. Create a new topic. I will then post the video on YouTube. If you feel like you need another session with more to cover some more in-depth topic, we can do that as well. Yeah, because I think that there was a lot of information to transfer here, and I did not have time to cover everything. So maybe I would have to come back with a more specific, with a more precise list of topics to cover. Meanwhile, I hope to see you soon. See you in the forums and elsewhere. Thank you for attending.
Great.
Bye, everyone.
Presentation.
Thank you.
Yes.
This is presentation.